Hello everyone, my name is Varnit Shukla and this is a video demonstrating my third DIY assignment, which is assembly and disassembly of a working household appliance. So here I have an extension board which is connected to a supply below, and if I push this button we can see that this light glows, which indicates that the extension board is working. I can also demonstrate using a phone charger. So as you can see, my phone is charging, which means that this board is working. And now I will disassemble this board. So there are four screws over here on the four corners. I have to remove these screws to remove this green outer covering of the board. So this is just made of plastic. It doesn't have any actual use. It just protects the main part of the board, which is this white part and what lies inside the whole circuit. This board has three connection plugs, one LED light and this switch. Also, the wire comes out so, and it can be collected by twisting this, shortens the wire, puts it inside. So I have disassembled this extension board, and I would like to just quickly go through the materials used in the making of this board. So these two covers are made up of plastic. This wire has a coating of PVC, and inside that there are brass wires. I mean, the main conducting material is brass. These strips are also made up of conducting material like copper or brass. The screws are made up of brass. These red, yellow and black wires also have a PVC coating, within which again there are copper brass wires. And the reason brass is used extensively in case of circuits is because of its great conductivity. The rest of the body is just plastic. So these are the materials used in making this extension board. Also, I have disassembled this extension board, and there are actually four main parts. So these two were the outer covering, and on the back side of this one, the specifications of our board is written right over here. 6 ampere, 240 volts AC only. So these are in fact the limitations of this board. This is the maximum current that can flow through this board. So these two are the outer parts. Now this is the main part of the extension board, the working part, and this is also actually can be divided into two parts. This white and gray one are separate parts. They can be separated. As we can see this gap right here, there is a slight space. So these definitely can be separated. They are connected using these screws on the inside, these two screws, but I can't remove them because the screwdriver is too big to remove this. So anyways, there are four main parts. So now coming to this working part of the board, let's start at the wire. So this is a 2-pin plug, and a 2-pin means there is a live wire and a neutral wire. There is no earthing wire. Uh, in case of 3-pin plugs, there is an earthing wire which connects the wire to the ground, which is actually a safety measure in case of electrical circuits. For example, like one of the plug points in this board can accommodate a 3-pin plug. The rest of them can accommodate 2-pin plugs. So those are the different types of plugs. One has an earthing wire, and this one does not have an earthing wire. This has two wires on the inside running through this. There are two wires which we will see in the main part. So and this gray thing is the sheathing of the wire, which is a PVC coating basically. So now let's come to this circuit. As we can see over here, the gray wire, from inside this gray wire there are two wires coming out, the red wire and the black wire. The red is called the live wire, black is called the neutral wire. So the live wire or the hot wire is basically connected to this switch right over here. So this is the wire which detects when the switch is on and off, because it's not that I as soon as I plug this into a main supply and turn it on, all of these plugs will be powered on. That's not the case, because this switch is also there. This switch also turns on and off. So this is kind of a second check, and this red wire detects whether the switch is on or off. And this black wire is connected over here. So this black wire carries the current to this silver area, which is sort of the junction of these three plug points. So this silver area is called a bus bar, which is basically a metal conductor which sort of attracts the current at one point and then distributes it, which we can see what is happening here also. So using the black wire, the current comes here and then it is distributed into three separate plugs, one right over here, one here, and then this is connected right here using this metal strip. So these are also basically conductors of different types. So as we can see, this wire carries current over here and connects to one terminal of the plug. This yellow wire on the other hand carries current from the switch to right over here, connects to another terminal of the plug. So the wiring inside of these extension boards is parallel kind of wiring, which means that these three plugs are connected in parallel supplies. And the reason for that is, in case one plug point fails, it does not mean that the extension board is completely useless, because these two plug points will still work in the case of parallel wiring. Whereas in the case of series wiring, as we know, current through all the boards will be same. So if any one of them fails, that means the current through that will become hindered. In other case, it will pass low current or maybe zero current, and which would also mean that the other two, even though they are in perfectly fine working condition, no current will go to them. So that's why these three plug points inside normal extension boards are connected in parallel connections. So let's once again see what the current flow is through this circuit. So I connect this to the main supply. The wire travels through this whole current, the current travels through this whole wire, and right over here there is a sort of check. The live wire is connected to the switch, so it will first check whether this switch is on or off. If the switch is off, then the circuit is not complete. So still these plug points will not work. If I connect a charger to this and the charger to my phone, it will not charge. Even the LED will not glow. If the switch is on, the live wire will detect that. It will see that current is should now flow through the circuit. So current flows like this. First, this black wire on the upper side, it takes it to the bus bar, takes the current to the bus bar, where it is separately supplied to three plug points, one terminal each of three plug points. This yellow wire supplies current to the other three terminals of plug point. We can think of them as positives and negatives. So this black wire say supplies current to positive plug points and this to negative plug points. And also there is another black wire right here. I hope it's visible. So it's right on this circumference, which is connected to the switch, and it passes through this thing over here. So this is the LED indicator. When the switch is powered on, current will flow through this wire as well and will go through here. Inside there is just a simple LED, red LED glows, which indicates the current is flowing. So this is the working part of an extension board, and now I will assemble all of this. Okay. So here I have assembled this board back, and now I will show that this board is still working. I will connect it to the main supply right below. So LED glows. My phone is also charging. So thankfully I have not damaged any of the circuit elements inside the board. So this is my final submission for the third DIY assignment, which is assembly and disassembly. I thank all the professors for giving me the chance to work with this. Thank you.